All right, today we're diving into a story that honestly sounds like it's straight out of science fiction, but it's happening right now in the world of pure math. So, picture this. There's this 200-year-old wall, a mathematical problem that everyone agreed was unsolvable, a dead end. But what if someone just claimed they found a way to smash right through it? Yeah, this is a story all about challenging the very idea of a mathematical impossibility.
And now brings us to this idea, which really gets to the heart of what we're talking about today. See, for 200 years, a whole class of equations was basically labeled unsolvable by any kind of general formula. That was the limit. But what if that was never actually true?
Or maybe, what if the original idea was just incomplete? That's the huge, high-stakes question we're looking at. We're about to dig into a claim that doesn't just poke at a settled mathematical law, it tries to rewrite it entirely. And let me tell you, that is a very bold move.
Okay, so to really get why this new claim is such a potential bombshell, we've got to go back in time. We need to understand the old rule, the mathematical law that's been on the books for 2 centuries.
You probably remember the quadratic formula from school, right? That one neat formula that could crack any second-degree equation you threw at it? Well, for centuries, the big dream for mathematicians was to find a similar master key for more complex equations. 3rd degree, 4th degree, 5th degree, you name it. It was this huge quest for one universal solution.
And for a while, they were actually making some great progress. Back in the 1500s, they cracked the code for 3rd and 4th degree equations. Things were looking good. But then, the trail just went cold. By the early 1800s, mathematicians started to think maybe it just couldn't be done. And then, in 1824, Niels Henrik Abel dropped the hammer. He published a proof that seemed to be the final word on the matter. There is no master key for equations of degree 5 or higher, period.
This became known as the Abel-Ruffini theorem. And here's the really crucial part you have to get. The theorem doesn't say that these equations have no solutions. They do. It just says there's no single elegant formula, one using just your basic tools like addition, subtraction, square roots, cube roots, that can solve all of them. And for 200 years, that has been a fundamental accepted limit in the world of algebra.
But like we said at the beginning, limits exist to be surpassed. And now a new challenger is stepping up, basically arguing that this 200-year-old limit isn't a limit at all, it's an illusion.
And that challenger is Professor Murad Sultan Ezouidi. His argument is pretty mind-blowing. He says that this so-called impossibility isn't some fundamental law of the universe. Instead, he calls it a historical misconception, an idea that only came about because mathematicians back in the 19th century were working with a limited set of tools. So, he's proposing a brand new framework called Ezouidi's theorem, and it's a totally different way of tackling the problem. Instead of using the old methods, it uses something called recursive transformations. The best way to think about it is like one of those Russian nesting dolls. You take the big, complicated equation, and the method transforms it into a slightly simpler version of itself. Then it does it again to that one, and again, peeling back the layers until, finally, the simple solution at the very core is revealed.
So just how different is this new approach from the old one? Well, let's put them side by side. This is where you can really see the clash between the old rules and these supposed new tools.
Okay, check this out. On the left, you've got the classical methods. They hit a hard wall after the 4th degree. For anything more complex, you have to rely on computers to get close, to get an approximation. The whole philosophy is basically, we accept that some things just can't be solved perfectly. But then look at the claims for Ezouidi's theorem on the right. It says, no, we can get exact solutions for 7th degree equations and beyond. It completely rejects this idea of mathematical fatalism. The huge difference here is the shift from just getting close to claiming you can get a 100% exact, perfect answer.
All right, so theory is one thing, but what does this look like in practice? Let's take a look at a specific example from the source material, a so-called impossible equation that was put to the test. Okay, here it is, a 7th degree polynomial. I mean, just look at this thing, all those terms. It's a monster. For 200 years, the rulebook has said that this beast right here cannot be solved with a general formula. Sure, you could plug it into a computer and get a really close decimal answer, but you'd never find the true, clean, symbolic solution. So for 2 centuries, that's where the story ended, with an approximation, a good enough answer. But the source material we're looking at today claims that this new theorem can slice right through all that complexity and pull out a perfectly clean, exact answer. You ready to see what it is? 4. That's it. The answer is just 4.
After that gigantic, intimidating equation, the claim is that the solution is a single, simple number. The difference is just staggering, right? So how on earth can one little number be the key to that whole monster?
Well, here's the really clever part. The claim isn't just that 4 is an answer, it's that 4 is the only answer, repeated 7 times. What that means is that the entire scary-looking polynomial from before was really just the simple expression x minus 4 to the 7th, wearing a very complicated disguise. And this is the big part, the claim is that this result was found using pure algebra. No computers, no approximations, no guessing.
So if, and it's a big if this claim holds up to scrutiny from the wider mathematical community, the implications are just huge. We're not just talking about solving one tricky equation. We're talking about potentially redrawing the map of what's considered possible in mathematics.
And this quote from the source really nails it. Think about it. For 2 centuries, when a mathematician said they were solving one of these complex equations, what they really meant was approximating. The goal of this new work is to change that definition back to what we all think it means, finding the actual, exact, perfect solution.
Now, this is a really important distinction to make. The claim isn't that Abel was wrong 200 years ago. Not at all. The argument is that Abel was 100% correct within the framework he was working in. What this new theorem claims to do is to build a new framework, a bigger one, with different rules that can sidestep the old limitations. It's not about breaking the old rules, it's about creating a new game.
So the ultimate vision here is pretty incredible. It's a future where the very phrase unsolvable equation just doesn't exist anymore. An era where mathematicians look at any polynomial, no matter how ridiculously complex, and know that hidden inside it is the blueprint for its own perfect solution, just waiting for the right key to unlock it.
And that leaves us with a pretty cool thought to chew on. The whole history of science and math is just a long story of things that were impossible until, one day, they weren't. So if a mathematical law that has been accepted for 200 years can suddenly be challenged like this, it really makes you wonder, right? What other big problems out there that we think are totally unsolvable today are just waiting for somebody to come along and invent a new way of looking at them? What's the next impossible domino to fall?